Hey everybody, in this video we're going to talk about how to count atoms in a chemical formula. So a chemical formula is almost like spelling a word. So here is a word, the word not. So it's got a spelling, it's got a meaning, you understand its meaning. But if I change a letter in this word, it's now note. So that's a completely different word and it has a different spelling. That's the same as chemical formulas. So you have to get the spelling of chemical formulas correct or the formula will be wrong. So here is an example of a chemical formula you're familiar with. Here is the chemical formula for water. So this is 2 hydrogen atoms and 1 oxygen atom. We know that there's only 1 oxygen atom because there is no subscript on this side. There is an imaginary 1 there, but because we just don't believe 1s are important in chemistry, so we never write them. Now, here is another chemical formula, and this one is not water anymore. That's now hydrogen peroxide. So there's a little cartoon in your notes there that you can laugh at. That is a totally different spelling in a new chemical formula. So spelling is really important and getting the subscripts correct. Here is another thing that's important, capitalization. So here is carbon. And if I put a big capital O after carbon, I'm looking at the chemical formula for carbon monoxide. If I were to put a lowercase o next to carbon, that's now the element cobalt. So see how capitalization is very important. If I put a 2 after this one here, then that becomes carbon dioxide. So each chemical formula is unique and the spelling is really important. So let's look at how to figure out how many atoms of each element are in a chemical formula once it gets to be multiple elements, multiple atoms, and it gets a little bit complicated. Here is a chemical formula for copper 2 sulfate. So this particular chemical has copper, it has sulfur, and it has oxygen. This here is called sulfate, and that is a polyatomic ion that we will talk about in a couple of weeks. But all you need to know now is that copper only just has 1, the sulfur only just has 1, and the oxygen is the only one that has 4. So when there is no parentheses and nothing else, you are only looking at the subscript that's attached to the 1 chemical symbol. So the 4 is only attached to the oxygen. So that's how we figure out how many atoms of each element are in a chemical formula. This is the subscript. Now, let's talk about coefficients. So a coefficient is a number that you put outside of the chemical formula to say how many of that particular molecule that you have. So here is a coefficient. It's a large number that's the same height as your element. So it's not a subscript that's little. It's going to be a big full-size number on the outside of the chemical formula. So let's see how the coefficient changes the number of total atoms in this compound. So the 3 is going to mean that we have 3 of the entire copper 2 sulfate. So there, it's really saying CuSO4, CuSO4, CuSO4. So it's like we have 3 of this molecule. So the copper total is going to be 3. The sulfur total is going to be 3. And then the oxygen total is going to be 3 times 4. So that's 12. Now that is how to count atoms that are in a regular formula with a coefficient. There's one more thing that gets a little bit tricky, and that is parentheses. So parentheses are used when we have polyatomic ions. So here is another copper molecule. This one is called copper 2 nitrate. So in this chemical formula, we've got copper, we've got nitrogen, and oxygen. So how many total so far? Just 1 copper. There is 1 nitrogen here, but see how this whole thing, this is a nitrate. That is in parentheses. So this little 2 out here applies to everything on the inside of parentheses, just like math. So there's actually 2 nitrogens here. And this O3, that 3 is attached to just the oxygen. However, there's 2. So we're actually going to multiply the 3 by 2, meaning that there would be 6 oxygens. Let's draw this out so it looks like it really is. So that would mean that there would be a copper and an N and 3 O's and another N with 3 O's. So 1 copper, 2 N's, and 6 oxygens. Now, if you were to put a coefficient in front of the copper 2 nitrate, you would have to just multiply each thing by that coefficient. So let's try copper. And we'll use a 3. So now that there's a coefficient there, let's see how many of each thing we have. Copper, there was an imaginary 1 here. Now there's 3 of them. For nitrogen, remember, always do the parentheses first. Again, just like math. So there's 2 nitrogens here, but you've got 3 molecules of it. So it's going to be 6. And then for the oxygen, there's 3 oxygens, but there's 2 nitrates, so that's 6. And then there's 3 molecules of the copper 2 nitrate, so that's going to be 18. All right, so let's try some practice. Hopefully that makes sense to you, and ask questions if you need to.